Okay, so for today's lesson, we're going to start something that we're going to be actually doing all week. So we're going to be doing what's called the double angle identity. This is, today is the 30th, and this is section 5.5. It's called the double. Whoa, hey, you're right. Spelled that wrong. Double angle identities. Oh, the mic quality should be a lot better this week. So, to get started, let's just recall the sum formulas. So there were three. One of them was that the sine of a plus b, and that was equal to the sine of a, cosine of b, same sign, cosine of a times the sine of b. There's actually three. Now what we're going to do is, instead of saying b, we're going to actually, it's called the double angle formula, because instead of having a plus b, it's just going to be a plus a. And this would turn into the sine of a, cosine of a, plus the cosine of a, sine of a, which gives us the formula the sine of 2a is equal to 2 times the sine of a, cosine of a. That's one of the formulas on your formula sheet. Let's do the same thing with cosine. So the formula for cosine of a plus b is equal to the cosine of a, cosine of b, opposite sign times the sine of a, sine of b. But if we instead write a plus a, we get cosine a minus sine a times the sine of a. So the cosine of 2a would equal cosine squared of a minus the sine squared of a. That's another formula on your formula sheet. But you could see that we could use Pythagorean identity, sine squared plus cosine squared equals 1, and substitute in for cosine squared or sine squared. So actually there's two other formulas that sometimes it's beneficial to use. We could always use that formula, but the other two formulas, if you use Pythagorean identity for cosine squared would be 1 minus sine squared, and we would get 1 minus 2 sine squared of a. And if we use Pythagorean identity to substitute in for the sine squared, this would be 2 cosine squared of a minus 1. Again, all three of those are on your formula sheet from last week that I gave you. And then the third one is the tangent of a plus b. The formula was the tangent of a, same sign, tangent of b, over 1 opposite sign times the tangent of a, tangent of b. Well, if we write a and b here, a plus a, we get tangent of a plus the tangent of a divided by, let's see here, this is going to be 1 minus the tangent of a times the tangent of a. So we do get another formula for a double angle. Tangent of 2a is now 2 times the tangent of a divided by 1 minus the tangent squared of a. So those three things that I highlighted, those are the, they're called double angle formulas. And I'll show you some examples with when we're going to be using them. Okay, so the first example looks like this. Use the triangle to find, and let's see what, here's a triangle. We'll put theta here, we'll put 5 here, 12 here, and I'm going to ask you to find the sine of 2 theta, the cosine of 2 theta, the tangent of 2 theta, and just to make things interesting, we'll also find the secant of 2 theta. Alright, so using our formulas, the sine of 2 theta would be 2 times the sine of theta cosine theta, which would be 2. Well, we need the hypotenuse. If we do Pythagorean theorem, we would get 13, or remember our special triangles would give us 5, 12, and 13. So 2 times the sine would be 5 over 12. Cosine would be 12 over 13. Actually, I misspoke. The sine of this triangle would be 5 over 13. And the cosine would be 12 over 13. So if we multiply all those together, we would get 120 over 169. The cosine of 2 theta, we have 3 formulas we could use. I'm just going to use the cosine squared of theta minus sine squared of theta. Could have used any of those. The cosine would be 12 over 13. The sine would be 5 over 13. And if you type those fractions into a calculator, you would get that the cosine would be 119 over 169. Now for the tangent of 2 theta, the formula is we do 2 times the tangent of theta divided by 1 minus tangent squared of theta. I'll just get a little bit of room here. And this would be 2 times the tangent, 5 over 12, divided by 1 minus 5 over 12 squared. And if you do this, the top would turn into 120, the bottom would turn into 119, and that would be the answer. What do you think the secant of 2 theta would be? Just raise your hand if you know. Oh, geez, I asked you to raise your hand, but all right, somebody yelled out we would just take the reciprocal of cosine. So if we know the cosine of 2 theta, the secant would be the reciprocal, 169 over 119. All right, so I have one other type of example for you. So if I asked you to please find the exact values of the sine of 2u if the cosine of 2u, find the exact values of sine of 2u, cosine of 2u, and the tangent of 2u if u is between 3 pi over 2 and 2 pi. And the cosine of u is 5 over 13. So we have a lot of information. This part says our u is between 270 and 360, which is over here. And we know the cosine of u is 5 over 13. So using special triangles or Pythagorean theorem, we know that this would be negative 12. So now let's figure out what the sine of 2u is, the cosine of 2u, and the tangent of 2u. It's not hard to do. You know the formula. So let's figure these out. First one would be 2 times the sine of u, negative 12 over 13, times the cosine, 5 over 13. And if you type that into your calculator, you get negative 120 over 169. For the cosine of 2u, I'm just going to use this formula, cosine squared minus sine squared. And cosine would be 5 over 13. And the sine would be negative 12 over 13. If you type that into your calculator, you'd get negative 119 over 169. And then for our last problem, it says find the tangent of 2u. So this would be 2 times negative 12 over 5 divided by 1 minus, let's see here, negative 12 over 5 squared. The top here would be negative 120, and the bottom here would be negative 119. So our final answer would be 120 over 119. All right, so that's today's lesson. What I would like you to please do for homework is on page 418. I would like you to please do numbers 1 to 7 odd. All right, thank you so much. Have a nice day.